get Anaconda downloaded successfully and installed? You probably don't know about it yet. So Anaconda is a packaging library for Python. It replaces pip and, well, it augments pip and replaces virtualenv, and just generally makes dealing with the things you have to build, like NumPy and SciPy, easy. I always, on my machine, I always have all the build tools installed, so it's never a problem for me to just pip install NumPy and it works. But a lot of people don't necessarily have that, especially if you're running Windows or don't have a Fortran compiler or something like that. So it's just a sort of nice package that takes care of all those dependencies for you. So what's your guys' general experience with Python? Are you guys beginner Python programmers, expert, never seen it before? Who has never programmed in Python before?
What do you mean, like what scale? Like what scales the?
It's
like
sort of it's an informal question. Do you feel comfortable that you could write a Python program to, I don't know, scrape some data from a website and put it in some sort of tabular format where you can present it? What's your guys' general experience with pandas and things like scikit-learn? Has anybody been exposed to any of that?
A little bit of Pandas.
Okay, all right. So I'm sort of learning this stuff as I'm going along too. I'm a professional Python programmer, but I have an interest in data and machine learning, and so I've been trying to pick this stuff up so I can learn it for my own work and to share what I learned with you guys. So.
Excuse me. I'm from that off. I apologize.
It's okay. So I've tried to become the expert so I can teach you guys, and this is sort of a good chance for me to learn how to do this stuff as well. Last weekend I went to PyData. Was anybody else there? Just me. So a lot of hey.
Hey John.
How are you?
Ooh, guys, I'm Vivian. Dog manager.
So a lot of the important people from the Python community were there. Wes McKinney, who actually is the guy who wrote Pandas, he did a talk, and Travis Oliphant, who wrote NumPy and SciPy, and is the CEO of the company who builds Anaconda. He was there as well, giving another talk. I have some links to the talks in here. There's some videos you guys will see. I'm not gonna play them because they're probably a few hours altogether, but it's I included them in here to show you that it's kind of cool that you can include YouTube videos in IPython notebooks, and to give you some stuff to take a look at later when you have the chance.
Do you mind?
No, not at all. The food will come soon, I hope. Okay. We ordered pizzas from Little Italy Pizza.
Oh, cool. It should be good. So it has the recording, right?
Yes, yes. And in fact, I'm recording right now.
Hi guys, we do really quick checking. Would you mind tell me your first name? Aaron?
Aaron, right?
Elliot.
Oh, Mark.
Mark?
I'm Matt.
Hold on, I'm not that fast. Matt and
I'm Matt.
and
I'm
Mark and Matt, sorry.
Devin.
I know you. Thank you for the help.
Yeah.
Gustavo.
Oh, how to spell that?
G-U-S. U-S-T-A-V-O.
J-U-S-T-O.
G-U-S-T-A-V-O.
Okay.
Yan, Y-A-N.
John Choi.
John Cardinale.
So how should I put
C-A-R-D-I-N-A-L-E.
C?
Cardinal with an
Would you mind I put John C?
E. That's perfect.
Awesome.
Matt also.
Last name?
Brady B.
B.
Michael.
Michael.
I'm good.
I know you. Kanya.
Shinichi.
Oh, yeah, I remember. I think you are the first Japanese in this group. And yours?
Jian, J-E-E,
J-E-E.
H-Y-U-N.
How to spell that?
Yeah.
F-R?
It's actually one of them.
I-E-D?
Yeah, R-I-K.
R-K-E.
Are you guys trying to access through the URL there? Oh, okay.
It's in a capital W.
S what?
Yes, that is.
S-A-D as in David, I-Q.
Okay.
Dina.
Lauren, L-O-R-E-N.
Summit.
I know you.
John C.
Dan.
Dan? Okay, the only reason I write your name is I'm going to thank you in my blog. Thank you for coming here. We aggregate all the material from workshop on the website, nycopendata.com. So all the video, all the source code will be reviewed, will be made available for you. Should we get started?
I think so.
Yeah. Should I just introduce?
Sure.
Yes.
Yeah. So, hi everyone. So, first of all, I'd like to thank OnDeck for hosting us over here. I'd like a special shout out for Vivian. She keeps organizing so many amazing events for us. So, the people who were here for the Python workshop 1 or 2 already know John. But John Downs, basically he has his bachelor's and master's in computer science, and he currently works at OnDeck. He has been programming in Python for quite a while, like several years, and his interests are machine learning and functional programming. So, sure.
Okay. So as I mentioned to most of you, I went to PyData, and I want to share with you some of the things I learned and talk about Pandas and the ecosystem that comes around it with scikit-learn and a little bit about matplotlib and some other tools. This is so what I'm showing you guys is an IPython notebook. I have the source code available on my GitHub, and we will take one moment to go deal with pizza.
Sorry guys, tonight we have pizza. Usually I order really good Chinese food, but the restaurant I ordered from had some kitchen accident. So this is the backup plan.
Do you want me to bring it?
Yeah, that would be great. I'll keep talking. So I want to talk about some of the ecosystem around pandas and the things that we can do to learn about data and to do machine learning. In case you are not familiar with Python and want to review, I've put up a couple of videos. This first one is just an introduction to Python from an open data perspective. And this next one is an introduction to pandas. And you guys can, I'm not going to go through them here, but you guys can watch those on your own time if you're not familiar with it. There's also a lot of good documentation, but sometimes watching a video is a good way to just get introduced to it. So probably the most important thing I learned about was Anaconda. Somebody had mentioned it a while ago and asked if I had tried it, and it was really being pushed at PyData. It's a replacement for virtualenv. It handles package management, and it takes care of all the difficulty of installing a lot of the tools for the SciPy stack. And it's cool, and you should start using it.
Is it paid or is it?
It is free. It is absolutely free. There are a couple of other open source tools. There's some plates down there. There's some other open source tools that they provide as well. They do mostly consulting, and they work on a parallel version that they'll sell you, and they have another platform called Wakari, which hosts IPython notebooks, and you can actually use this as like a cloud computing platform. It has all the tools installed in it. There's a pretty good free tier that gives you a lot of disk space and some enough processing power to do something like this. And they'll charge you for the higher tiers because it runs on Amazon Web Services. But you probably couldn't run your business on the free tier. But if you want to play around and just have it hosted and be able to share with people, there's definitely a free tier. So they're pro open source.
Can you quickly show us how to use it? Because I downloaded it, I installed
Yes.
it, but then
So I'm just learning how to use it. But the package management system is called Conda, short for Anaconda. You can create. So this is your command to update update Conda if you installed it last week and they've pushed new updates. This here, Conda create, actually creates an environment for you to do your experiment in. You used to work with virtualenv, which created an isolated system where it had a specific version of various packages. It had its own Python interpreter, and it was really good, but it was a little weird to work with sometimes. What this will do is it'll create a new environment called demo, and I think these are the packages that it installs. So it installs the base system Python and pip, and then you can get started with that. You'll source it, puts on your path an activate command, and an activate script which has the environment variables that you need. So this will actually activate the environment that you created here, and you can get started. Let me show you on the terminal. So if you type conda info, it'll actually show you a little bit about your setup, where your base environment is. If I were to create a new environment, I think it would show up here as well.
Use yours.
Sure.
Let me use her. Join me. Did you use this before?
Yes, I do.
Okay.
I don't know if I've used it on this machine.
Fine. You just go ahead. Sorry. It's really hard to see from back end.
So it basically replaces virtual EMV.
Yes, yes.
Okay.
It's a complete replacement for VirtualEnv. Stop using VirtualEnv, use Anaconda.
You don't need to install anything else. It installs all the
Yep,
dependencies.
it will install the dependencies. It also handles installing new packages. There's on the website where you download it. There's documentation. It's pretty good.
And if I have my environment already, it will not mess up with it?
No.
All my
No.
pip install stuff?
I found actually when I installed Anaconda, I didn't have a lot of the packages that because it pointed to a new environment, so I did have to go through installing like the latest version of the Postgres database. But those, when you try something out, you get an import error. You'll see it. You type pip install, and you get your stuff back pretty quickly.
Okay, I got link. Everyone can access this desktop from join.me/NYC. Can you put a big editor and make it bigger?
Yep.
Do you have Sublime
I don't.
or any text editor? Use one. We were going to make it bigger. Type the name Chrome and make your Windows bigger.
What's the command to make the windows bigger?
Just open an email or something. Just make the windows bigger. Does that work?
I'm not sure how to zoom in to.
Yes. So. Aaron. What editor are you using?
I use Emacs mostly.
Can you see it from the back? It's join.me/NYC-open-data. Awesome. Just type your name and click on Knock to join. You will be able to see the screen from your own laptop.
Sorry, for this position,
It is welcome with a lowercase w. Welcome exclamation. It's right up there, slightly misspelled. For join.me/NYC-open-data. Let's actually take this off. So there's a big stack for the machine learning ecosystem that Python has, and most everything is built on top of NumPy. This is it's a MATLAB replacement. That's probably the easiest way to describe it. It handles vectors and matrices, and there are some basic statistics you can do on a vector. You can take the mean of all the values. You can do some linear algebra, and this is really meant to be fast. NumPy, a lot of the actual algorithms are written as C extensions. Has anybody actually done a C extension for Python? So you can write C modules with a particular interface, and let Python know that you've created this, and actually call these C functions from Python, and they'll benefit from being compiled code. So sitting on top of NumPy are SciPy, Pandas, and I don't know if the Matplotlib uses NumPy as such, but it's sort of on the same level. Pandas is a database. That's a very controversial statement. It does things like let you select rows and columns, get views of your matrix. You can merge and join, and you can group by. A lot of the things that you can do as from a SQL database, you could do from Pandas. The difference is Pandas is always in memory, so you're limited to not being able to use really big out of core data. There might be some ways around it, but nothing's really really easy to do out of core stuff with Pandas. But it's basically a really fast database that lets you move stuff around in memory, create the views of the data that you want, and then go on to work with it. And there's some basic tools that come with it for doing statistics on what's called a data frame, and it's very similar to the R data frame. I'm sure a lot of you know about it. Matplotlib is what we use for visualization. It's just it's a graphing library. It's pretty easy. There's a plot command with a bunch of arguments that lets us make graphs. A lot of the objects from Pandas, the series and the data frame, all will let you just use a plot method right on them. Wow. So SciPy was actually written by the same person who did NumPy, and it has a lot of the scientific programming stack. It does linear algebra, it does statistics. You can do optimization. You can do Fourier transforms. You can do all sorts of things. Scikits are extensions on SciPy that don't really belong in the core library. Part of that has to do with team size. This is a pretty big library, so there's only so many people who can work on it to make an effective team. So if there's interesting things that somebody else wants to do, or if it isn't quite ready for inclusion in the core, then it'll be broken off into a scikit. The two ones that I'm familiar with are scikit-learn and scikit-image. Image is for image processing. Scikit-learn is a big machine learning library, and it makes using a lot of interesting machine learning algorithms pretty easy. Stats models is another library that handles some statistical functions. It also has it will interact with R and actually pull the R data sets. That's one of the interesting things I saw. So if you've done something in R and you've worked with that data set and you want to try something out in Python and see if you get the same results, they're in stats models. this convention, import NumPy is NP. When you use IPython, there's something called PyLab, which imports a lot of these modules by default, so that you have them in your desktop, I guess. And this is just the convention that they're called with, so we're going to use that. The basic data structure that NumPy has is just it's an array. You can either treat it as a one-dimensional array or a multi-dimensional array. It's called an ND array for n dimensions. You can make identity matrices, you can make zero matrices, and you can see them here. They're sort of a standard Python data structure. You can view it like a list. So if you want to just do indexing, and you can grab the first row off a matrix. It's row ordered. So when you pick things up, you're picking out rows and not columns. Because NumPy is compiled, you can only have one kind of thing in a NumPy array. So in a Python list, you can have anything. It's not typed. But in a NumPy array, if I try to put a string in here, it'll throw an exception. And it's that strong typing in the array is what gives NumPy its speed, because it doesn't have to do any runtime checks when it's actually computing. It also supports something called fancy indexing. So rather than just using the numerical slices like you would in a Python list, you can say things like, I want all the x's that are greater than 3 from here. So if this, for each element, if this is true, then you'll get that element back. And you can see here, I just pull out a vector of all the things that are greater than 3. It also handles two-dimensional slicing, like you can see there. There's something called a universal function in NumPy. And a lot of the functions in NumPy are universal functions that take 2 arguments and then return some result. And you can write your own, but here's some examples of them. Add, you can take the log of everything. You can find out what's greater than 3 and actually get a Boolean array back. So I think I misspoke. These are element-wise, and so they're just things that operate on every single element. There's a lot. I'm not going to enumerate them all during the documentation. If you type np dot and tab in your in IPython, you'll see all the different things that are here. There's also a matrix data structure. It behaves like a MATLAB matrix, if any of you have used MATLAB before. It's not really how things are done in NumPy, but it's there to make it easier for you to use if you're a MATLAB user, because we want you to use Python instead of MATLAB.
I have a question.
Go ahead.
How can you do 1 times 1, 1 times 2 till 9 times 9 in this matrix?
So you want to multiply each element by a
Element-wise.
Element-wise. So in the matrix you can't. Back let's see. So when you start an IPython notebook, it starts with a clear environment, and then you can execute each one of these cells. So I haven't executed this since I wrote it. So NumPy is not in my namespace, so that's why I'm including this here. There's a multiply function, and you want to 2, 3, 4, 5, 6, 7, 9.
Array can do element wise.
Yeah. So that might work.
Do you want to do X? Both X here? X and X here? Does that work?
Yes, is that what you're looking for? So you see this multiplication here is element-wise. In the matrix, when I do multiplication, it's actually the dot product, I think. So that's one example of where matrices and ND arrays are a little bit different, and it depends on where you're coming from and what you expect from that sort of operation.
What if I want to do a dot product on NumPy array?
There's actually there's a method called dot. So
Okay, can I use an operator?
can you use an operator? What do you mean by that? Like that?
Okay, so for a function not using like multiply by operator.
Right. There is no. Yeah, there's no operator that operates on NumPy arrays to do that sort of multiplication. To do a dot product. If you want to do a dot product with an operator, then you need to use a matrix. So that can make it look a little bit cleaner. But if you return a matrix from some function, be aware that a lot of the rest of the stack expects arrays. So yeah, so you need to make sure you keep track of what your types are. Are there any questions about NumPy? So SciPy is the other, if you guys remember the diagram, SciPy was over here just above NumPy. And it's got a bunch of libraries. There are, on the SciPy website, there's a page full. It's a lot of the common things you'd expect to see with MATLAB. I talk a lot about MATLAB because it's what I have more experience with. So most of the linear algebra stuff is in NumPy. SciPy has a wrapper around some of it, and if you want to use some of the more advanced functions, you should take a look at what NumPy has. But we're gonna take a look first at some of the things that SciPy can do. So we're using the same sort of convention. We're shortening the name of the module, so we keep the namespace, but without having to pollute our line with a big long name. So what I'm doing here, I want to solve the linear equation AX equals B. And so I create a random matrix, a 5x5 matrix. I create a random vector of random values that's 5 values, and I just call linear algebra.solve. And I want to know X. I give it A and B, and it solves X for me. So this is my random matrix of floating point values. This is my random vector, and this is the solution. It's pretty quick. It's simple.
We should totally do a benchmark between R and Python.
We can do that. There's a magic function. Yep, that is it. There's two versions of it, actually. One like this with a single percent sign in front of it. You wanna type a command after that. And so what it'll do is it'll run it a number of times based on how fast the operation is. The IPython will actually figure out. It'll do an initial iteration and it'll say, okay, I have a second or two to complete this. So how many can I get? And it's 777 microseconds per loop for solving a 5 by 5 times a 1 by 5.
If you're running the linear algebra, I assume you can get errors on that. How do the errors appear to you? Do they appear as part of the answer? Do you do a try-catch statement, or what do you do?
I don't know.
Why don't you just try it?
What?
Let's see. You have 2 rows of the same thing, with the same numbers in it.
Okay, so A equals...
Right, but you're writing a program, and how do you catch it? Right.
Can you guys hear John all right from back?
So we think this, I'm repeating the two lines here. There's actually a linear algebra error. And it will tell you that you have a single matrix. So you'd wrap it in a try-catch.
Yeah.
The other time it function, because I mentioned the other one, has 2% signs, and you can use it to time an actual block of code. So if you want to time a function, just write it out. You can do that. You can find eigenvalues with eig. You can do QR decomposition. QR. And there's a bunch of other factorizations that you can do. Singular value decomposition is similarly easy. You can use this, the singular value decomposition, to compute the condition number of the matrix. NumPy also has a similar function in its, so NumPy has a linear algebra namespace in it where you do a lot of the linear algebra functions. There's a nice one for figuring out what the condition number is. This is a flag. It will, you'll see in the documentation there's like 5 numeric flags. There's 5 different ways that can compute the condition number, and you just put this flag in the end of it, and it will it'll calculate it for you. I've used it. I've used NumPy and SciPy linear algebra a little bit, and I find that not having matrices as a first-class object like you do in MATLAB is a little weird, but it definitely makes up for the MATLAB not being a really general-purpose programming language. So being able to use Python more than makes up for the little bit of weirdness of that syntax. So there's also some statistics in SciPy. NumPy has summary statistics. You can calculate the mean, you can calculate the standard deviation. Nothing really advanced. But SciPy does give you a lot more in its stats package. So here's the first time I'm going to show you guys matplotlib. So we're importing pyplot, which will do our plotting for us. As PLT, SciPy, from SciPy, we're importing stats. And we're going to make a log normal distribution. I don't know exactly how to explain this.
You know something? Anyone can help?
So I forget exactly what numargs is. So with IPython, yes.
No, option enter will run what you want to.
I do not.
Yeah, option.
Thank you. If there's something that you want to read the documentation on from an IPython notebook, you can type the thing that you want with a question mark after it, and it will give you a sort of a console that actually has the documentation that you want. And this also works in the IPython shell. If you are doing this on the command line and not in the notebook, you'll still get the same documentation. In this case, numargs is just an integer, so that doesn't really tell me much about what it is. But here I'm using matplotlib to actually plot the distribution, and there are a number of probability distributions in SciPy. There's a page full, so you can work with different probability distributions. So. You can get some descriptive statistics. it actually returns a set of values that you can see here: the size of the data, the minimum, maximum, the mean, the variance, and those come back as NumPy arrays. You can calculate the z-score of each element. You can calculate. Pretty much everything is as you'd expect it with a really normal sort of name. But it does have a very rich set of statistical libraries.
There's something similar to ANOVA.
I believe there is ANOVA in SciPy Stats. I am 99% positive that I've seen that.
How about time series?
Time series is
Do you do Pandas or?
yeah. There's a lot of functionality in Pandas for time series. I haven't really touched on that. I haven't had to do anything with time series, but I know that's one of the big things that Pandas is strong in. Wes McKinney, who wrote it, he used to work at a hedge fund and dealt with a lot of time series data, and that was the problem that he was solving. So you can look at sliding windows in Pandas. You can calculate an ongoing mean. All the things that you would do with a time series that are really you're going to want to look in Pandas for those things. I was looking at the scikit-learn website, and they have a lot of really good documentation with examples, and I found this, which is a flowchart that tells you if you have, you can figure out what sort of problem you have and what sort of machine learning algorithm you want to apply to it. So it covers 4 areas. You can do some supervised learning classification. You can do unsupervised clustering. There's regression and dimensionality reduction, and those are the big things that you can do with it. And this I haven't actually worked through the flowchart, but it seems pretty straightforward, and it will. You can see things like you should have more than 50 data points. If you end up here, you need to figure out what your problem is. But this will let you work with scikit-learn even if you're not totally familiar with all the algorithms. So you don't actually have to know how like a support vector machine works or a naive Bayes classifier. The reason for that is that there's an estimator interface, and so everything that scikit-learn gives you is an estimator. So you fit training data to it, and you predict based on your testing data. So in the case of fitting the data, this is for supervised learning. The first argument is the training data set that you have. And the second argument is the list of labels that you want to classify on. For unsupervised learning, you just fit to X, and it will do its clustering, and there's no labels that you know beforehand. When you're doing supervised learning, there's also a score which will tell you how well your estimator is doing. Unsupervised estimators have transform, and I am not really familiar with that. Is there anyone who understands transform for unsupervised learning? Can you explain it? I guess I'll leave that as an exercise. So scikit-learn has some data sets too. I'm sure everybody's seen the iris data set. So from scikit-learn, I have data sets. There's another one that does handwritten digits. There's another one for with some images. You can explore this data sets library. But I load the data set that I want. There's for each data set there's a load function that creates an object with the data that you have and what's known as target, which are your labels. And so these are the sepal width and sepal length and stem width and stem length, maybe. But here are the three labels just as numeric values. And so these are the X and Y that we're going to use in a classifier. So we can visualize the data. And we can make predictions on the data. So there's for each classifier, there's another namespace. A lot of things are broken up into namespaces, so we can find them, and there's no pollution of names. I just give the number of neighbors 3. I call fit, and if I want to predict the result of some new iris that I found, I call predict with the values that I want, and it gives it to me.
Did you calculate the error rate?
I did not calculate the error rate. There is a method in here that will give you a number of the statistics on it. I'm forgetting the right word, but you can get all the different the different ways you can evaluate the quality of your estimator.
ECDF, or what's that called? Roughly.
ECDF?
Good answer.
So if you guys want to try this out with a support vector classifier, do any of you actually have the notebook open so that you can use it? So in this case, SVC is going to be the same. It's going to be just like the neighbor's namespace. And if you type SVC dot and hit tab, you'll see your list of options. When someone is finished, they can raise their hand and tell me if they got the same answer. set the unsupervised. Okay. Reduce channel. Okay. So those who have tried this, you guys almost there? What answer did you get? And you use the same prediction values? There are, I'm not really prepared to talk about it, but there are some tools that will let us take a look at how the various estimators are doing, and we can see which ones are doing better. And it could be very well that we get different answers with different classifiers. But that was more an exercise to just get you, typing out the commands so you can see how that interface works. So one of the things I mentioned for unsupervised learning was dimensionality reduction, and there's a method called principal component analysis. This data set is in 4 dimensions because we have the length and width of the two different portions of the flower. So in this case, what I want to do is I want to reduce this to 2 dimensions, and I call the fit method just like before. In this case, I use the transform method that I failed to explain earlier. So in this case, what it does is this transformation actually reduces the number of dimensions that you have. So there's 150 data items in the reduced set, and it's only 2 dimensions. Again, we can plot it with in PyLab, which is it's another library that just has a high-level interface for a lot of these tools. We can create some of the plots. There's a scatter plot in this case. The fourth portion that we had was clustering. I'm doing k-means clusters. I have 3 clusters. I fit my data. I do some prediction, and I plot it. So the important thing to remember about this is that everything just has this easy interface. So you can try out different classifiers and see what they're doing. And really, it makes it easy to explore these ideas. So apparently I thought ahead, and I talked about the validation. There are metrics that we can use to judge the accuracy, precision, recall, and F1 score. There's also a cross-validation library that lets me, if I have a whole data set, I don't want to just train on the whole data set because I'm going to overfit. So I can, with this train, test, split method, break up a data set. This is the same X and Y earlier from the iris data points and the labels, and I can break it up into training and testing sets. And so in this case, I run the same classifier that I asked you guys to do earlier, and I can here measure the from the metrics model, I can calculate the accuracy, precision, recall, and F1 score.
So if we just change the SVC to another classifier,
Yep.
we should get the
Yes.
actuals.
Yes, you could, and to change this format, all you would need to do is change this line for a new classifier and create your new classifier here. And then that should just actually work.
Why is there a parentheses in front of SVC and nothing?
So SVC, this is actually a class. So there's the SVC classifier, it becomes an object. So in this case, I'm just instantiating the object with no arguments.
Oh, okay.
So it's not just a module. It's an actual object with some state. Here I actually do some cross-validation with the support vector classifier. In this case, I'm breaking the test set into two pieces, just right down the middle, and I'm running it here with the cross-val score, which comes from sklearn cross-validation. I give it the classifier and the information the classifier would take, and I give it some scoring method, and then it will actually it'll run it on both sets, and so we can see the accuracy of it both ways.
Why is split train and test half-half?
No reason. That was just an example. It's not necessarily the best way to do it. Usually you'd want to split it 80-20 or something. This was just an arbitrary down the middle. There was at the end of the PyData conference, there were some lightning talks, and something I haven't talked about much is matplotlib. And I've shown you the couple of plots that you can do from various places. Matplotlib is sort of scattered everywhere, so a lot of things you can plot them. But the plots are not necessarily the prettiest, and there was somebody who created a different library. So it's a wrapper around this with some prettier defaults. It's called Pretty Plotlib, and you can see the box chart there. It looks a little nicer. If you actually go to the GitHub repository, you'll see some other examples, and they're just things that she spent a lot of time in her code fighting to get pretty plots. So I was sort of impressed with it. So I thought I'd plug it.
So is it really just kind of like an aesthetic thing, like structurally it would be pretty much the same?
Yes, it is. There's nothing you can't do with matplotlib that you can't. There's nothing you can do with prettyplotlib that you can't do with raw matplotlib, right. Except that you'll spend a lot of time writing a lot of code. You'll write 30 lines to do something that you can do in one with prettyplotlib. One of the things that I was impressed with, you guys have seen the images of like a covariance matrix, and you'll see the positive and negative values, and it's washed in color, and it's hard to tell what's what because because of where the scale is. In this case, the darker colors will be positive numbers and the lighter colors will be negative numbers, and so it sort of moves the middle value to 0. So it's a little easier to see what's going on. So this video is here for your enjoyment, but this is for later. This is Wes McKinney, the creator of Pandas, actually did a talk there. He tweeted the night before that we should get working on his talk, and so this was done with some minimal preparation, but he is an expert in the subject, so I encourage you to watch it. It's he called it medium data analytics with pandas. But that's not really what it is. It's 11 things he hates about pandas, and it's definitely worth a view so you can see what some of the limitations were. He talked about a lot about comparing pandas to a database, and he said, well, maybe I should just admit that it is in fact a database. You also see another project that he was talking about, another project that he's working on now called Badger. He has his own company in California. He's working on some similar problems with pandas that pandas would be a solution for, but there's the data is too big. So Badger is his solution to that, and he's spending his time working on that. And it's interesting to see what's being worked on, and it's he's not open sourcing it yet because he doesn't have the time to manage an open source project. But his big complaint was that with Badger, he doesn't have a lot of people to help him with some of the core analytics algorithms that he's working on, and that was a problem with Pandas as well. There's some features that maybe you'd have in R, but nobody's actually written the algorithms for Pandas yet. So there's a lot of room if any of you want to contribute to Pandas. It's on GitHub, and there's a ton of algorithm work that does need to be done.
So, like currently, when you're using Pandas, what would be an example of like when your data would be too big, and what would you do to resolve that issue if you're having it with Pandas?
It depends on how much memory you have. If your data is too big when it doesn't fit in memory anymore, that's really the only time it's too big. It's not. Pandas can handle arbitrary sized data, but if you have a terabyte of data, you don't have a terabyte of RAM. So you either buy a supercomputer or you find another solution. I've heard that there is a way to work with HD5S, which is sort of a database layer on top of your file system. I don't really know how well that works. Generally, if your data is too big, you need to find another solution other than Pandas, or make an extension to Pandas. You guys have heard of the Netflix competition? So there's an open data with movies. It's got movies, users who have rated the movies. It's available here. When you're using IPython Notebook or just the IPython shell, if you have an exclamation point, you can actually use a shell command, and it'll execute that in your working directory. If you do something like cd, I don't know that will affect where your Python process is. It does? Okay. But you can download files, you can unzip files, you can apparently change directories. you'll get your shell output right in the notebook here. So when I get the data, I want to take a look at the README. This is just a basic open a file, read a file, print a file. When you print to the notebook, if you guys can see this, it'll give you a window that you can look in and scroll through, so it doesn't take up your whole screen. But if you click on the side here, you'll actually get the whole thing as you can scroll down as its own window. The data in here is a little, it's in a bunch of different formats. Some of it's tab delimited, some of it's pipe delimited. Reading it is all the same thing. I just tell it what the separator is, and I can get the data that I want. When you read it with Pandas, it gives you a data frame back. You guys who have not seen this, Pandas can handle multiple data types in a data frame, but only ever one data type in a column. So if you have something that's a string halfway down your file, you'll and you expect something like age to be an integer. If there's a string there and it reads it as a string, you'll see that the type here becomes an object, and that reduces the functionality that Pandas gives you. When you have floating point and integer values, Pandas can do a lot more things because it's numeric. Like I said, Pandas is a database. You can do the merge operation is just it's a left join. There's actually a parameter in there that lets you do an inner join or a right join, and it puts all our data in one frame to work with. I did notice that you couldn't join more than one table at a time. If you want to keep tacking things on, you need to do that as a series of operations.
How do you do outer join? Left inner, left outer?
There's actually a parameter in the merge method that lets you specify as a string, I think. It's either that or it's a Boolean value. I don't. A lot of the Pandas functions have a lot of different parameters to them. There can be in the docs you can see two little lines, and it can be there's a lot of functionality there. And in the sometimes you'll give a Boolean value for turning something on or off, or you'll give a string parameter if it's something like joins. And I think that joins would probably have a string because it's not just two options.
Inner, outer,
inner, outer, left, and right. So yeah, that would probably
full join.
Yeah. So that would be a string probably.
How does it handle the cases where you don't have a match? So if you did the left join and then your right data set had some values that on the key that weren't in the left join, and would it just like punk it on, or how does it?
It's my understanding that works just like a SQL join. So if you have a left join and your right has data that doesn't fit here, that will just get dropped. But if you do a full join, it will give you everything, and then you'll just have null values on the side where there wasn't anything.
Right. Yeah, just like
Yeah. So once we have a data frame, we can ask questions of it. We can plot histograms. There's a couple of other graphs that we can do from this.
Question about data frames.
Sure.
One of the issues in R is the existence of factors in nested calls.
Okay.
Does Pandas have the same issue, or does everything, all strings held as strings? You understand what I mean by factors?
No, I've heard the term before, but
Well, what R does is that it'll take a column
Mm-hmm.
and it'll figure out all the unique elements in there, and it'll code them as this is the first type of element, this is the second type of element. But when you print it out, it looks like a regular strings. But internally, it's actually not strings. It's pointers to strings.
Mm-hmm.
And so if you try to do operations on it, occasionally R will get confused. So you're doing operations with factor numbers
Mm-hmm.
as opposed to doing operations on strings.
In Pandas, when you have a string, it's stored as an object, and it will be treated as a Python object. If you have some function that you apply across that series, so a data frame is a matrix, and it consists of series, which are vectors. If you have a set of objects that are strings, and you want to do some operation on them and see if they match a regular expression or something, you can do that as strings. They're not actually they're not encoded as anything.
Okay.
So is there the concept of like an enum? You know, it's actually an integer, but it has a label.
Not really. Python doesn't have an enum. There is a. You can use dictionaries to create enums to map. To map some value to a number. Are you familiar with Python dictionaries?
Yeah.
But no, there's nothing that's actually an enum
that,
like you'd find in C.
I can answer a question. When you make data frame in R, you can add the parameter called string as factor equal to false.
Yeah, that's what I end up doing. But the problem is that generally that's not the default.
It's not the default.
Yeah, and so you end up with all this crazy and some very, very bizarre results coming out.
Factor is handy. It's not an issue. You need it for regression. It's the grouping parameter.
Yeah, especially if you have something like you want to do a numerical operation on it, occasionally it will get very confused. You have to do take the character value of that and then convert it to a numeric. And that's how you actually get the number, you actually get the correct number.
That's the charm of art.
The columns in the data frames have labels. So you can index a data frame in a number of ways. You can index it with you can say I want the third column, or you can say I want the movie titles. You can access those like a dictionary. You can actually, in the square brackets, pass title. Or the data frame does some magic and actually gives you this as a something you can use with a dot operator, and it's your preference however you want to do that. But that's just another way that you can access the data. Being able to split up your data is probably the thing that Pandas does that's most important. So there's 100 different ways that you can get to it. I've never actually counted, but this value counts here is a database-like operation. It does a group by, and actually counts the number of items you have in each group, and then you can treat that as just another NumPy array. everything that you remember about NumPy earlier, about the fancy indexing will also work with this. And so it's really easy just to get your top 10 items or top n items with simple slicing. This was a talk that I saw earlier, and I have left this as an exercise. But this talk was part of the NYC machine learning group, and the speaker goes through how to make a recommendation engine using a lot of the things that I've tried out here. And I think there's actually enough in these slides if you guys wanted to try to make a recommendation engine that you could out of the data in these slides if you follow this talk.
Would that be, I mean, I guess as an exercise it would be great, but like in terms of practicality, is that on par with whatever else they would have used to create their recommendation engine? Or does Python have advantages that the other way wouldn't? Catches and
what you were
should I just watch the video?
This wasn't done in Python. This video doesn't. It shows how to use singular value decomposition to get the data in the ways that you need it to be able to classify, and talks about using some various classifiers, but it doesn't actually touch on any of them. Python will let you will just let you implement it, and Python is it's production worthy. It's as a language, it's used for real websites. It's used for real analytics at real companies. Banks use it all the time.
Spotify uses scikit-learn for their recommendation system. They use Python.
Yeah. So this is a real tool that you can use. And if you dig into it a little more, stats models I know has some functions that actually let you build more robust, better tuned models. And I believe that scikit-learn lets you do some hyperparameter optimization on the different classifiers, so you can tune it for your particular problem. So it's a real tool. You asked me about the big data earlier. So if your data is too big, Pandas probably isn't the tool that you need, but you can use if you can break the problem down into things that you can do in memory, you can use scikit-learn. You can use NumPy to solve your problem. It's real tools that are used by real companies to solve problems. This is tangential to the SciPy ecology, but this was a talk about generators and using generator functions to stream data. And I highly recommend you watch this. This is probably my favorite talk, so I wanted to just include it at the end. I think it's maybe a better program having seen this, so I highly recommend you watch this. Are there any questions?
We still have time. Shall we start
Yeah.
a new tradition? Anyone have?
Can you go over a little bit about what is actually in this talk about generators? So we cover it at a very high level.
Yeah, so I assume that not everybody knows what generators are. Let's learn something. So range creates a list that's stored in memory, and then for x in range, print x. It iterates over that and gives you the whole sequence right now. That's great until this turns into billion. All right, who here notices that I've written an infinite loop? This is a generator function. The magic here is in this yield statement. And this acts just like return. So in this case, I return one value. But the difference is it pauses the execution here. So the next time I call the generator, it will go back up to the loop and evaluate it again and give me the next value. You can see this is actually a generator object that I've created, and I can treat this as a lazy sequence. So it's one thing to have all the integers. It's kind of neat to have that on finite machine. But the real value here is if I'm reading some file that's too big in memory, and I just want to return the next value and process it, then I can do that. If I do have this, there's an itertools library that I don't know well enough to live program. I'm sure you haven't used that. But what it can do is it can take a slice of 10 values, and so I can get the 10 values and work with those. And I can just keep using this generator object until it runs out. You can have finite generator objects or infinite generator objects. When you run out, it will throw a stop iteration error. But you can do anything with this generator object that you can with a list or any other sort of iterable item. And the actual next item isn't evaluated until you actually need it. So rather than having this huge object in memory, when you hang around when you don't need it, you can wait until you need it to evaluate it. Another thing you can do with generators, if you have some sort of finite list that you want to generate, if I make a list and return it with some a million values or something, it's something I can reasonably do. And you want to cast it as a tuple or some other kind of iterable data structure. You have this list sitting in memory, and so you have to make another copy of it. With the generator, you can just feed that into the tuple function or the list function, and you can actually get the values that you want in there. It's only created once. It's really fast. This has been pretty well optimized. So.
Is this what you wrote here? Is that similar to how X-range or X-range?
Yes. X-range makes a generator.
So that's a generator that's built in to the Python library.
There's generators everywhere in a lot of libraries, and so if you've done a moderate amount of Python programming, you've encountered a generator, and you may just not know.
Thanks.
You're welcome.
Anyone have cool stuff on to show? Anything cool?
Actually, a question.
Sure.
Could you tell us I'm just curious about what's going on here at
On Deck Capital?
right on Deck Capital in terms of its usage with Python, specifically these particular packages.
Well, our data scientists are very silly and use R.
Oh.
And so that's why I made him come, so that he'd learn about a real programming language.
We do love R. We're looking at some other things. Not that we have any particular problem with R, but like scalability is a concern, and the libraries are just as good or better, maybe worse. It depends what you're doing for R, but I think the main impetus for moving to Python-based machine learning is that we do everything else in Python. So like all of our GUI code, all of our stuff that interacts with our Unix processes and everything, it's just much nicer to do in Python. So we're kind of hoping for like a more unified, just like from a knowledge standpoint, get good at one thing instead of knowing all these different languages. If one can really do everything the other can.
I read a blog post today about how it was somebody who's doing some data analytics. She's a PhD in machine learning or something. And 5 years ago, her workflow was, she used a little bit of R for this, a little bit of Python for this, a little bit of Java for this, and some Unix tools for this. And she talked about her workflow as it is today. And it's a whole lot of Python and then a little bit of branching out into other things when something isn't quite right. So she still uses R when it's the right tool, but most of the time is spent in this one general purpose platform.
After this, you still want to use Python?
Well, it's pretty similar to R.
But R spring is much prettier. Yeah, the result, the ggplot, or everything.
Oh yeah.
The summary statistic.
Yeah, that stuff's pretty good. But I'm not in charge of producing plots. I produce predictions and everything.
I'm assuming in terms of time though, it's essentially the same thing, like the benchmarks are the same.
Yeah, there's places where they'll outperform each other a little bit, but Python is competitive. If you're at the point where you need to shave off a couple microseconds, you should be using C. But if R is fast enough for you, then Python will probably be fast enough for you as well.
Let's do a benchmark. How
Okay.
many of you will come? Comparison between Python and R code.
I just wanted to comment about R. There's just so many advanced packages in R that R actually competes with a package like SAS on a lot of ways. It doesn't have the data model that SAS has, obviously, but it has packages that can
Which model R doesn't have?
SAS obviously can deal with vast amounts of data that the 64-bit version of R. Although I have to say my brother works with microarray data, and they're able to analyze that data with the 64-bit version of R. So, I'm sorry that this is an R club.
I'm excited about that too.
Yeah.
SAS has a pretty good, like if you're not thinking about distributed computing,
That's right.
SAS is really good
For structured data,
It's really
structured
fast.
data does a lot of stuff.
But if you're going to go like do something like, with multiple, I mean, I don't know much about that world, but like if you're going to get out of one computer, then maybe SAS. I don't know how that works.
Well, I think like the one thing that appeals to me about Python so much is the fact that it's a programming language as well as a statistics package, a graphical package. It's so many things, it has such a wide range. Whereas R, in a sense, has a certain narrow scope, just the analysis things that really, you only do so much outside of the realm of statistics.
Yeah.
You know,
R it's a complete programming language.
Yeah.
but it's really a domain-specific language for doing statistics. Like MATLAB is a domain-specific language for doing linear algebra.
Right.
And when you go outside those domains, things get hard to do. And that's why, if you have something where you need one of R's statistical package for it, to solve your problem, and Python may not have it. It doesn't have a lot of those things because the R has years of traction working on statistics packages before Python even thought that this is something we can do. So by all means, if that's your problem, use R. But if that's not, but you also need to present it on a website, you need to scrape data, you need to do all the other things that you do when you make a full application. Use Python. The biggest weakness of Python is in multi-threading. Python doesn't actually support multi-threading. There's a global interpreter lock, which only lets one thread run at a time. It's really heavy-handed, and when you use threads, I've used threads to get around a stopped process. If I know something might hang, I'll use a thread to get around it, but I never use it for parallel computation.
So what is like the threading module do?
It threads, but they're terrible. They're not actual. They don't run on separate processors. They're run inside
on different servers.
If you want to, there's a multi-process module that lets you actually fork a new process with its own PID. If you want to do something on a different server, you need to have some way to communicate with them.
I switched to mine.
It's okay.
Like on the local machine,
Yeah.
will run multi-thread on that.
Yeah, they're threads. You'll get parallel execution, but you won't get any sort of performance out of them. Your performance will be terrible. It will be worse than if you had a single threading application. There are people working on that. That's sort of the big problem that exists with Python for a lot of applications. So it's an area of research. My screen's been stolen.
Okay, I take it over. This is the cool visualization tool. You can take out anything you want and turn off stuff you don't want and take it back. And you can see the data right here. It has data view. And you can bring it back.
What tool is this?
It's called eCharts. We're adapting it into R. And next one. The spike was like their Thanksgiving sale. It looks like an outlier. If you take it out, this is the real sales pattern. And you can use different demonstration. You can take any point out. Jack.
How do you get this?
My team did this.
Okay. But you said it was based upon something else.
Yes, but
Is there something else available?
yes,
What's it called?
it's called eCharts.
Okay. And was it standalone or is it package in R?
It's a library of JavaScript, and you can decide what you really want. But click through of them.
Is it built on? Like, how does this work under this browser?
Let me show you the whole story first. And you can decide what demonstration you like. This one, you can decide which range you like.
Look at this color showing.
This one, you can drag the time range you want. And focus on the area you like. And turn something up and turn it off. And see the data point right beside it. How many points you guess it's in their spot? How many? It's 1/3 of 1 million points. We can take a closer look. Only MATLAB can do it right inside of the software, but R can do it here.
Well, technically you use JavaScript.
But we'll make it easier for a statistician to use.
So this gives me a chance to plug my other favorite programming language, which is Clojure. Clojure is a Lisp that runs on the Java virtual machine, but it's also been ported so that it compiles to JavaScript. So you can write Lisp that compiles to JavaScript and does things like this.
And this one is dynamically loading your data and demonstrate it every 2 seconds.
But it is pretty
Cool, right? And you can turn whatever you like or combination of them.
Is this built on top of D3?
No, separate library.
Oh, really?
Yes, but Professor Ramnach is adapting it into R charts. Another good reason to use R. See, you can turn this up, turn this off, and choose whatever you like.
Is there a Python version?
See, I use R to make these slides. I teach R class, so I just wrote everything in R. It's a pretty one, right? It's a HTML5 one. You can read it on the phone without any problem.
Closest thing in Python is probably D3. It allows you to use D3 but write it in Python. There's some basic. It looks similar to that. So if anybody is using Python, then it's nice looking graphs.
What is it called?
NVD3. Reusable D3 charts.
Do you want to teach us about this?
Oh no, I don't know too much about it. I can just pick up ones.
That's how I got roped into teaching Pandas. It's incredible.
Yes! Do you want to try? Do your homework and teach it?
Maybe, but I'll help you.
Okay, cool. Everyone listen to Aaron. He said he might do it. Cool. Who else have cool stuff on show us?
There is also, for the Python win, there's a RPy module which will let you interface directly with R, and anything that you can do in R you can do from Python with this module.
Any of you used knitr before? Knitr. You can call knitr. You can use knitr to call R and Python at the same place. Have you tried it?
No, I haven't tried that combination.
Okay. Actually, I recorded Yihui's presentation last time. He showed us how to do Python and R in knitr. I will share it at our website. This is the website for this meetup. I just thank you guys, but maybe I misspelled some name. I will fix it. This is the video for last event. Binding data to the DOM. The video is available. Any of you went to that one? Aaron, did you go?
Was this the second one?
It's the Adam Pierce one.
Yeah, it was really good.
Do you still have the code?
Yeah.
Send to me, please.
Okay.
And last week we did 2 events on location data query. The whole point is to teach how to do the New Yorker subway visualization. So that's why we did it in 2 parts. The first part is showing you how to exactly to do the D3 part. If you scroll down, we recorded the whole stuff. And the first slide is about how can you get data from census and prepare for your D3 visualization. And the second slide explains everything you should do with your D3, step by step. I think it's easy enough to follow along, like how to generate the map, how to generate subway line paths. And on Thursday, professor from Dartmouth showed us how can you do location data query. This is their 17-page slides. And Devin just sent me their Mac version. This recording is Linux version, and we are working on the Windows version now. It will be fully compatible. So, make this website your good friend. What else? Anything interesting you want to hack? Something as cool as this one?
Is there any other data that we could combine with this to learn something? This is a pretty straightforward question. It shows you how wealthy people are, or how poor people are, particularly that stuff. I wonder if there's more data on the NYC open data.
This one doesn't exist on NYC data. It's the census data.
Yeah, I know this is a different data set, but is there some other data set that we could get to maybe answer some interesting questions? I don't know what interesting questions would be yet.
Do you remember I taught our basic here once?
Yes.
I showed how to do the mice sightseeing, like which cross block have the most mouse.
Yes.
That's the good one. That's 311 service data. And they also have tree data, so we know which season you can expect to see blooming flowers.
I saw a thing once, I read after seeing this, where the person was doing something where he was kind of cleaning up data that you can get on the MTA site on swipe information, and we had to kind of do a lot to estimate from it where it kind of only records in certain ways, like when people swipe into stations. The idea was to kind of get an idea of like traffic flow throughout the system.
Oh, okay.
But
I have to show
it was like
this one.
hard to, you had to like make some guesses on how far somebody actually went, but it was pretty interesting.
That's interesting. That
So-
Maybe this or something, I don't know.
This is the site Chicago did. They have all the open data based on Chicago government, like
With crime.
yes, they have crime in Chicago. And how's the business in Chicago? Like how much murder you can expect happen in this season. They have the past 11 years. I'm working on the lobbyist one. I want to make a New York version. This one. Who's the most highest paid lobbyist? Who is the highest paid lobbying firm? Most active clients? Most lobby city agency? I'm working on this one. Anyone want to join me?
Is that open data?
Yes. Because the Sunlight law requires you to report any income or payment related to lobbying.
Campaign contribution only, or is it?
Anything you have to report if you're going to hire someone to lobby. This one is quite interesting. We can just take it by. I don't know.
There's a rumor that Chicago as a city has better open data and better use of their open data. And I think it's very unfair to let Chicago win it. So we should.
The weird thing is, in the rank of 10th most smart city, New York was ranked like the 4th. Chicago was 10th. But they have all the really stunning showcase. This is public school tiles. It tells you which area is, like the dark blue part is the rich and good school, if you're familiar with Chicago location. Tile for median family income.
Cool if you could like zoom in and get it even finer.
You can.
Oh, you can.
Yes, you can.
If you-
It's good Google Fusion table. So
Oh, I see.
everything's supposed to be like work like Google Map.
Right. Oh, cool.
And do you have anyone ever lived in Chicago in the past? We can try some address. I'm in the process to do average cases for New York. So if you want to join me, talk to me. Awesome, that's it. That's all we have for you tonight. Hope you had a good time.
Thank you, guys.
Thank you.
Oh, I also have the city bike data. We scrape from the website every 5 minutes.
I wonder if the subway it's the same problem as the
Yeah, we could compare them, like to see what ridership stop each station is.
Look, it looked like this. So this is like one record. You will find station ID, station bin list, location, available dock, available bikes, status, whether it's in service or out of service.
One of the problems with this, well, no, it's not a problem, but with like flows, is that they replenish the bikes with like trucks all the time. So
It doesn't matter because this is the actual responding data in the station.
yeah, but I mean, it doesn't tell you, yeah,
It
But,
updates every 5 minutes.
yeah,
Even they're loading and adding bike, it's still accurate.
yeah.
So this data you will be able to put it on the map and see which one, just kind of like the app that you get on the phone.
I tried to do a prediction model. So like today, I want to know whether I can get a bike at this location. I will look back like 10 work day before today or the past 10 Tuesday. It can tell me roughly how much percentage I can get bike today.
Are they pretty
Yeah,
consistent?
based on the time of the day and the location.
Yes.
Yeah.
Sounds
I've-
good, right?
I've heard there've been a
That's
lot
cool.
of problems with people going to a station and there's no bikes, or they have one at the station.
We can return it.
Yeah.
Did you?
Yeah, what are the
model to
chances that
that?
it's full?
Yes.
What's that? If you want to share what?
I haven't finished it. It's
Oh, you
still,
haven't
yes.
installed.
Mhm.
Oh, that would be cool. It's very cool because then you can know, oh, it's not likely that I can return my bike, in this one versus on the other one.
Mhm.
Also. Thank you.
Someday, some point
I sent you what I had on that.
Okay.
It was just the, I don't know, whatever he made available, his tutorial folder. So I'm not sure if that's what you need.
No, I mean the live
Oh, you want my stuff?
Yeah, did you remember he showed a few live coding stuff? People are trying to follow along.
Yeah, all of that stuff is in the, like his index.html.
Okay.
It's all in there because I went back the
Exactly
next
the same thing?
day. Pretty much the same.
Okay.
Yeah, because I wanted to redo it because I couldn't see a couple things. So that's how I went back through and I made.
Can you show me where it is?
Yeah.
So it's, believe me, yeah. It's pretty awesome.
Thank you. Aaron, I give you a seat. It didn't came.
Yeah, when was that? I didn't have one to the visit one, right?
You got a spot.
Because I asked and it said it was full.
Yeah, I do.
And I
do
said-
Selenium
I-
tests, so we have to work around
Gosh.
I do some service tasks.
Okay.
What's some of the department you mentioned?
We've class. Yeah. I've used it before, but it's a little too heavyweight for a lot of the stuff I do.
I'll show you. I've seen our running something like company. It's a great idea.
So you like comparing which part where you read this in R, right? Yeah, I do the same.
I don't know, like, do you guys have that app?
Yeah, we have an actual a web app that you can, if you're a small business owner, you can log in there and do information. You'll get a decision. If you're not outright rejected, one of our salespeople will help you try to work with you.
We'll upload stuff to that or enter manually.
I understand.
So some of our stuff is customer facing. We also use a lot of tools to help the salespeople. Yeah, you're welcome.
Combining
I'll tell them
chat and shiny
Bye, John. Yes. It's really cool.
It's a good place.
Thank you. Coming back from work.
Yeah.
Bye.
Check out this notebook and go through a little slower.
Hi, sir. I haven't catch your name. John.
Ah,
Is this okay? Okay. You like it? Yeah, come back from work.
There's actually, on the Pandas website, if you go to the documentation, there's
Actually,
a
I
using R
got
Python
required.
portion in the help. And it's the R Python that will actually import and run R. Because they're both C coded, so they're, yeah, so there's a way to interface it. That's been done with the R Python.
Is that efficient or really good?
I don't know. Really try it. It's. I'd guess that it's reasonably efficient because the people who are working on it are the same who've worked on they're worried about making it efficient.
Oh, where's mine?
So I couldn't confirm, but it's my guess that
I was looking at the
pretty performant.
city bike data before. So if you, when you do that, like, how do you
actually see
find out whether it actually works.
So you could take something like you could take just build a regression, time and then time
Right.
You can deploy it and try. Thank you for coming.
Yeah. They'll just be on like a loop and then they'll just.
I usually do things in Ruby on
Do you have any books to recommend to use the stat model? Are you aware of
stats models. No, I do not. The other reason is the first time I was exposed to it. The stats models, I did look at the stats model website. And I'm not really a statistician, so I'm not a lot of it. But
Yes, so
I've seen
here,
the
like,
documentation.
yeah.
Thank you for coming.
It's good, it's very complete.
Here's where he did.
Almost done.
Here's where he did his little intro,
what
like
is the
his
website?
name, and he wrote all this
If you just,
out.
yeah, if you just Google
There.
Vivian, can I disconnect here?
Sure.
Okay.
Go ahead.
Each one of